going to be talking about population dynamics. I initially chose this topic because I'm interested in actuarial science, because it helps find out about insurance and pensions. A population is a group of organisms of the same species that can live together and can reproduce. A population is dynamic. This means that it's constantly changing in size and demographics. Population growth is a change in number of individuals in a population per unit time. The size of a population, NT, depends upon the initial size of the population, the number of births, the number of deaths, the number of immigrants, and the number of emigrants. Therefore, the equation is NT equals N0 plus B minus D plus I minus E. When a population is closed, there is no immigration or emigration, and this can happen on small islands such as the Galapagos Islands. This would change the equation to become NT equals N0 plus B minus D. Clearly, the population would increase if B is greater than D, and decrease if B is less than D. Per capita rates. It is important to rate the basic population parameters such as births or deaths to the size of the whole population. This would allow us to make a better decision and assess the risks involved. We define the per capita birth rate as B is equals to the number of births over the size of the population, and the same can be done for the number of deaths, which is the per capita death rate. Then we move on to talk about the first model, which we use the equation NT plus 1 equals NT plus B minus D. This equation can help us find the per capita death rates, and we do not need the per capita death rates because it does not affect the size, and this would change the equation to become NT plus 1 equals NT plus B NT minus D NT from here, and we can factorize these equations to become NT plus NT B minus D, and this is R, which is the geometric rate of increase. R can also be written as the change in the total population size over the population size. And then we can change this equation to become NT plus 1 equals NT plus RNT. And we can introduce lambda, which is 1 plus R, which we can get by factorizing. Which is the finite rate of increase, and the equation for lambda is NT plus 1 over NT, and lambda can be interpreted as the ratio between the population size at one time to another time. I have some questions over there that will help us understand the real life applications of this topic. Okay, so the first question asks about the mortality as per capita death rate, which we can use this equation to find the answer. And the answer would be 20 over 850, which is Then the next question talks about population increase, which we can use this equation to find it, and the answer would be 1000 over 850 to give populations. I'm going to move on to talk about geometric growth. The population equation can be rearranged to make nt plus 1 the subject. It means that over discrete intervals of time, t0, t1, t2, the rate of change in population size is proportional to the size of the population. And the equation, the final equation in the geometric growth model is nt equals lambda t plus n0, and the population size will depend on the value of lambda. If lambda is greater than 1, then there's an exponential increase. If it's equal to 1, there's a stationary population. And if it's less than 1, there's an exponential decrease. There's another question. This will show you the value of r and the value of lambda. We can use this equation to calculate the value of r, which would be 40 over 100, because the change in the population is 40, and the total population size would be 100%, and that is 0.4, and lambda would be 1 plus r, which is 1 plus 0.4, which is 1.4. Okay, that's it. You have any questions? Yeah.
So for like a country like the UK, England, what would be the values like B and D, roughly? Like lowercase b, like the birth and death rates.
I'm not sure, but I think at this point, I think there are quite a few births.
Mm-hmm.
But there was a time when there was not that many births, and I think a few years ago there was a higher death rate in England.
Okay.
Yeah. And yeah.
What are the benefits and limitations of using this model?
Okay, the benefits are it is easy to use once you have the equations and the data, and the limitations are because it's a discrete in time intervals. That would mean that you wouldn't have all the data, and a continuous model may be better to use. Any other questions?